Beyond Clean offers a creative look into the inner workings of a healthcare industry committed to getting it right every instrument, every time. Join us every week as we explore the hidden world of one of the most important aspects of safe surgical care. And now your hosts, Hank Balch, Michael Matthews, and Justin Poulin.
This week on Beyond Clean, we speak with Brandon VanHee, Clinical Education Manager at Key Surgical. Brandon has over 10 years of experience in leadership positions in the United States Marine Corps and the healthcare industry. This experience led him to work with various medical device companies in product management, new product development, clinical marketing, and clinical training roles. Currently, Brandon is the Clinical Education Manager for Key Surgical. He plays an active role in promoting infection prevention best practices in sterile processing and flexible endoscope reprocessing around the globe. Brandon is also currently working to identify and promote sterile processing best practices as a voting member on AAMI ST Workgroup 84, Endoscope Reprocessing, and AAMI ST Workgroup 93, Cleaning Reusable Medical Device Committees. Brandon volunteers 2 days a week at a local sterile processing department and is currently working towards CRCST, CER, and CIS certifications through ISHM. So, Mike, this is something I know you love, the microbiology. Wava Truscott was somebody you really wanted to talk to on this show, and Brandon's pretty new to Key Surgical. We've had one person, Lindsay Brown from Key Surgical, on the show in the past, and definitely looking to talk to Brandon for the very first time.
Yeah, I'm really excited about this particular episode because this is a very, very hot topic right now in the industry. You know, we've talked about it kind of in a number of episodes. You know, we talked about WAVA, and I think we talked about it a little bit with Sarah Freiberg when we talked about flexible endoscope reprocessing. There's a lot of interactions with this particular topic, but we've never had a show just on biofilm formation. And it's critical to the outcomes in healthcare that, you know, go through our hands. So this is very exciting for us to have him on here to talk about this, and I just can't wait.
All right, well, before we get started, a reminder, you can subscribe to Beyond Clean on iTunes, Stitcher, Google Play, and Spotify, or search for Beyond Clean on your favorite podcast application. We can also be heard on the Sterile Education app, which is available on iTunes and Android. Follow Beyond Clean on Twitter at Beyond Clean Info, Facebook.com/Beyond Clean Podcast, LinkedIn.com/company/Beyond Clean. Our Instagram page is Beyond Clean Podcast. If you have a future topic or guest that you'd like to recommend for the show, or if you'd like to share a picture anonymously on our Instagram page, send an email to info@beyondclean.net. Finally, check out our new and improved website, beyondclean.net. That's where you will find the quizzes for our Season 2 episodes and earn CE credits for listening to these shows. Season 2 CE credits are brought to you by our sponsors, Innovative Sterilization Technologies and Petrus. The One Tray System. Are you tired of playing catch-up? Now you can process your vendor trays and other high-turn hospital-owned surgical assets in a fraction of the time it takes with sterilization wraps and other rigid containers. Maintain one standard of care, eliminate wet and torn wraps, and save your facility money. Efficient, safe, storable, durable, and secure. Invest in the best, the One Tray System by Innovative Sterilization Technologies. And Petrus is an advanced sterilization intelligence company built to maximize the management of manufacturers' IFUs, drive regulatory compliance, and deliver quality products safely to the patient. The Bluefin software utilizes algorithms and complex systems designed to combat common daily errors being performed in sterilization departments across the country and around the globe. For more information, visit PetrusInc.com. That's PetrusInc.com. Beyond Clean. Joining us now is Brandon VanHee, Clinical Education Manager at Key Surgical. And we had, I think, your predecessor, Brandon, on the show, Lindsay Brown, a while back, and we talked about brushes. And our topic today also harkens to a couple of episodes that we had with Wava Truscott. So the term biofilm has come up several times in our first, 52 episodes that we've done, and it's about time we talked about it. So we're very happy to have you on the show to talk about biofilm today.
Yeah, thanks, guys. I'm a huge fan of the show, so I'm really excited to get into the nitty-gritty and talk about biofilm.
Excellent. Well, let's maybe just start by talking about biofilm, what it is, and how it differs from terminology you hear very frequently in the industry, which is bioburden.
Sure. Yeah, that's a great question. So in our industry, I hear biofilm, bioburden, and soil actually used interchangeably quite a bit. And although all three of those are really related, especially when we're talking about cleaning and disinfecting and sterilizing medical devices, those three terms really have very distinct differences as well. So soil, on one hand, really refers to the organic and inorganic debris that's present on an instrument or a flexible endoscope, let's say, and it can be made up of a multitude of different things like blood, bone, cartilage, fat, and other tissues. But there's also some other things that it could be, like bone cement and other compounds that are used intraoperatively. And bioburden, on the other hand, is really the total number of microbes that is living on a surface. So this is really kind of our starting point when we talk about cleaning and disinfection. So each step of the medical device reprocessing workflow really removes a portion of the original bioburden, starting in the OR at point of use cleaning, and then really ending in the sterilizer, right? So by the time we get out of the sterilizer, we're really counting on that bioburden to be reduced to zero, or at least we're counting on a very high probability that that bioburden has been reduced to zero. Now, biofilm, which is what our topic today is, really a mixture of kind of soil and bioburden together. It interacts with soil, and without bioburden, you can't have biofilm, because that's when we're talking about the microbial count on devices. But biofilm is really a specific type of microbial community, and it forms in a thin layer, hence the term film, and that can include many different types of microbes, so not just bacteria, but it can also include yeasts and viruses and protozoa and archaea, and all of that is held together in a matrix, and that adheres to a surface. So that's really the difference between those three terms, and like I said, they're very distinct in their differences, but we talk about them quite a bit as if they're the same thing.
All right, so Brandon, that's great, but again, can you zero in on why does this really matter for the sterile processing technician out there?
In the Marine Corps, we have a principle, and it's to know your enemy. So that's a pretty simple idea, right? But it's a really valuable concept. So the way that I relate that to CS and SPD professionals is the more that you know about your enemy, right, the more easily you'll be able to identify their strengths, but more importantly, you'll be able to identify their weaknesses so that you can exploit them on the battlefield. And in SPD, you know, our professionals, our techs, are really on the front lines in the war against hospital-acquired infections or healthcare-associated infections. And we often refer to our techs being in the trenches, right? And in sterile processing, we have a lot of enemies. So we have increasing complexity in instrumentation, misaligned or contradicting guidelines, ambiguous IFUs for cleaning and reprocessing, and then, of course, we have tight budgets, right? But I would consider that one of our enemies that has proven to be the toughest really is biofilm. And in fact, a study that was published in Science magazine found that up to 65% of infections in the developed world are caused by microbial biofilms.
Yeah, that's great. I remember when that study came out, it sent a lot of waves out because no one had really, I don't think, considered the impact that something as simple as a biofilm can have. And oftentimes those are the most chronic infections. Those are the ones that people never seem to really get over. So kind of following that same train of thought then, you know, what kind of impact does the formation of biofilm have on the cleaning of the instruments?
Sure. So the one thing that I always like to point out is that, you know, these microorganisms have been evolving for millions of years. And over that time, the ability to form biofilms has increased their evolutionary fitness. So it's just like with Darwin, the survival of the fittest. And the microbes that have been able to proliferate and continue to pass on that trait. And you can find biofilm everywhere. I mean, it's the plaque on your teeth. It's the slime in your dog's water bowl after a couple of days of not changing it. The water lines in your house. And, of course, you guessed it, medical devices, right? So biofilm is really this incredible process, and it protects all of the microbes that are underneath it. And I can really get into the nitty-gritty on how biofilm forms and what processes happen in the middle. But I think that the key takeaway is really that these microbes are protected by a film, and that film prevents them from being reached by disinfectants, by detergents, and often by sterilization. And so that protection is really what makes biofilm incredibly impactful and incredibly dangerous in the healthcare field.
All right, so Brandon, can you go in specifically to how these microorganisms, when they form the biofilm, how that actually happens?
Yeah, and like I said before, it's this really incredible process. So I'm going to nerd out a little bit here and give you, some really detailed information. But I can tell you right now, if you're not interested in this, I don't know what else you could be interested in. It's pretty incredible. So really, what biofilm takes, the requirements for a biofilm to form are a surface, usually water or a fluid, and really it only takes a single microbial cell. So once that bacteria or other microbe has settled onto the surface that we were talking about, it'll begin to multiply, because that's what bacteria like to do, right? That's their job. They just want to create more bacteria. And biofilm formation really requires a specific population of bacteria. And often it has many different types of bacteria and types of other organisms, like I said before. But this is where it really gets interesting, right? So since biofilm formation is dependent on how many bacteria are present, the microbes use a process called quorum sensing. So it's a molecular signaling system that helps to communicate with other cells. So the bacteria send out chemical signals to each other, and then they're kind of pinging each other like on radar, right? And the number of the signals that the cell received is dependent on how many other bacteria are around them. So if enough cells are present, the frequency of those signals will reach a threshold, and that will really trigger a change in what genes are being regulated within the bacteria, and that causes the bacteria to initiate a different process. So after we get enough of the bacteria, enough microbes in one place, then the bacteria start to produce these thin fibers. They're called pili. So they use these to attach to each other and to the surface that they're on, and they use them to move closer to each other, adjust their position, which is really called twitching motility. And once the cells are in the optimal position and attached to the surface, they excrete an extracellular polymeric substance, which we call EPS. And really, essentially, it's a sticky slime that's made up of different proteins and polysaccharides and nucleic acids. And this EPS really cements the cells together, and it provides the support and protection for the microbes from its external stressors. So these stressors could be antibiotics or detergents, disinfectants and sterilants, or it could be a stressor like desiccation, so trying to dry them out. And this protection is really, what makes it important to cleaning and sterilizing medical devices. Because not only does it make them extremely difficult to remove, but it can also increase the chances of developing antimicrobial properties. So, for instance, a bacteria in a mature biofilm can be exposed to multiple rounds of sublethal doses of disinfectants or antibiotics, and the most resistant cells will continue to thrive. Then, through a process called horizontal gene transfer, which I won't get into the details of that, but these resistant organisms, they can transfer their resistant traits to the cells around them and cause this resistance to spread extremely quickly. So that's why this is really important, and that's what makes it so difficult to tackle in central sterile.
Yeah, and along those same lines, kind of the example that I use pretty regularly when I'm doing my education stuff is, I'm from Arkansas, so I think pretty much everybody in my area has had the experience of walking in a creek and you feel sort of that slippery substance on the rocks. That's kind of the biofilm there being created. So, I would imagine that the layer of biofilm kind of has that property of being hydrophobic, meaning that it repels water. And, that has a lot of impacts on the instruments as well, right?
Yeah, absolutely. So, when we talk about detergents and disinfectants, really our cleaning detergents and things that we use in decontam are some of our best tools along with brushes. But those tools are really what help to separate through processes using enzymes and processes using surfactants to try and help pull that away and penetrate that hydrophobic kind of slippery cell membrane. And so you're totally right. It becomes a big problem.
All right, Brandon, so I'm sitting here and I'm convinced. I understand the importance of understanding this topic. I realize now a little bit about how it's formed. I have a lot more self-study to do after your description, but super interesting. But now the question is, in my everyday life as a sterile processing technician, I'm seeing instruments come by me either through decontam or in the inspection section of the department. Are there particular instruments and equipment that I need to be taking a look at that are at a higher risk? Obviously, you're going to inspect everything, but is there anything that should really be setting off warning flags that we know have a potential and a greater risk for harboring biofilm?
Yeah, absolutely. So really, the instruments that are most at risk are those that have complex designs. So cannulated instruments, instruments with multiple lumens, flexible endoscopes. We know those are incredibly complex. And especially those that have really small diameter lumens, like I said, flexible endoscopes. So the real reason behind this is that those places are extremely difficult to clean. And we all know that if you can't clean it, you can't disinfect it or sterilize it, right?
So, and I guess that probably reinforces how important cleaning is, specifically, in the ORs or, in the GI labs where these things are first being, taken off the field. Time is of the essence.
Yeah, well, I think we can all agree that instrument cleaning and disinfection, sterilizing, that process really starts at the point of use, right? Both, AAMI ST 79, ST 91, and a lot of other guidelines specify that point of use cleaning is the first step in successful reprocessing reusable medical devices. So, like I said, I think we can all agree on that. But with that in mind, point of use cleaning is really the first step in preventing biofilm formation. So ensuring that gross soil is being wiped from the instruments intraoperatively, so during the middle of the procedure, and that those instruments are being rinsed and flushed is really extremely important. And one other key step that we can take in the OR to prevent biofilm is applying a pre-treatment spray, gel, or foam, whatever the product is, to the instrument sets prior to transfer. So instrument pre-treatment products typically will keep the instruments moist to prevent soils from drying and adhering to the instruments. And many have bacteriostatic properties, which will prevent the growth of biofilm forming bacteria. So that's a really key step in ensuring that at the time that the instruments are done being used in the OR until the time that they start manual cleaning in decontam, that they're being worked on essentially by this pre-treatment product in that time.
Brandon, that's great talking about what needs to happen at the point of use in the OR, but what are some things that can be done in sterile processing as well?
Once the instruments leave the OR and they're transported down to the SPD, there's a few important things that we as CS professionals can do to prevent biofilm formation. So the first one, and we talked about this a little bit, is the prompt cleaning of instruments. So as soon as they arrive in SPD, and I know that sometimes that is a lot easier said than done, especially when you've got cases stacking up or you're short-staffed, but starting that manual cleaning process as soon as possible is really imperative to preventing biofilm formation. Biofilm can form in a matter of hours, and the longer the instruments sit, the more difficult it will be to properly clean them. Another thing that we can do to ensure that we're brushing and flushing all instruments. So this is a huge piece, especially your cannulated instruments and instruments with multiple channels. Every single channel should be brushed with an appropriate size brush, and mechanical force applied by that brush is really the most effective way to disturb and remove the biofilm. Without proper brush bristle tip to surface contact, we really can't generate that friction to remove the biofilm. So that's why it's so important to have brushes that are the appropriate size. And then brushing, when combined with flushing with an appropriate instrument cleaning detergent, is really the best combination for removing that biofilm. And I know we discussed this before, but one last thing that I just wanted to touch on as well is to really ensure that we're properly inspecting every single instrument and removing any damaged instruments for repair or replacement. So not only do bacteria love to hide out in complex and cannulated instruments, but they really love to hang out in those damaged areas as well. So scratches and pitting, other types of damage, that really provides a haven for microorganisms to grow. And as we know, those areas are nearly impossible to clean. So keeping a close eye out for damage and removing those damaged instruments from use will really help prevent biofilm formation in those areas.
This whole line of thought is all over AAMI guidelines, starting in 79, and I think it's in 91 as well. Feel free to correct me if I'm wrong there. And I also know the Joint Commission recently came out and said this is going to be a point of emphasis for the coming year, is this point of use cleaning and what's going on in the OR. And you're right, the amount of time it takes is a big factor in how effectively the instrument can be cleaned, how long it takes when it leaves the OR until it gets to the SPD and decon. So let me just ask you, knowing these challenges, what are some successful, I'd say, strategies for getting the OR's attention and really helping them understand the importance of this? Have you seen any cool things out in the field that might be really beneficial for the listening audience to try to help them figure out how they can raise the awareness on this?
Yeah, so it's funny that you mentioned that because I've also heard the same things, right? I've heard the Joint Commission is really cracking down. I've been in several facilities that, just in normal conversations, whether I was in doing an educational seminar or just talking to the technicians there, and they said, oh, we just had the Joint Commission come in, and they actually cited the OR because the instruments were coming back to decontam too soiled. And so the Joint Commission has really taken a step forward in revising what their scoring is and how they apply that to the different departments. Because really, if you think about it, if the instruments are getting down to decontam or down to the SPD and there is, tons of gross soil on them, there's really not anything that the SPD and CS professionals can do at that point except for make the OR aware that these things are helpful. And one thing that I've really found, or at least that I've heard to be successful, is cross-training. In a lot of facilities that I've been in where the OR techs and SPD have been able to spend time essentially in the other person's shoes to understand that the longer that, these instruments have gross soil on them, or if they don't have the appropriate pre-cleaning steps that are happening in the OR at point of use, then they're getting down to decontam and showing the OR staff that that's what it's like when you're trying to remove those soils and you're really trying to reprocess those instruments, and the extra time and effort it takes in order to get through that. That's been really successful from a lot of facilities that I've heard of. So being able to cross-train and spend some time in the other person's shoes has really been successful.
Yeah, that's so interesting, Brandon. And of course, that's an answer, I think, to a lot of challenges, if it's biofilm or if it's just professional communication, having folks understand where the other side is coming from. Huge step forward, obviously, in a lot of these departments to struggle with culture even. But I wanted to go back. You said you were going to nerd out a little bit on the formation aspect, and let's just say that you recruited a couple more nerds on this episode, and they're like, I want to know more. How do I become up my department, biofilm expert, what are some resources that you use to educate yourself, or are there any YouTube videos or anything like that you can point the listeners to find out more about what we're talking about on this episode?
Yeah, absolutely. So there are quite a few resources out there. One thing that I found really, really helpful a while back when I started to really get interested in biofilm and to kind of understand and kind of know my enemy, right, as I was saying before. And YouTube has been a really great platform. So honestly, I used to just go in and I would type in Biofilm Formation in YouTube and see the hundreds of videos that would pop up. Some of them great, some of them not, but that's an awesome place to start. And there are also quite a few educational resources provided by a multitude of of companies out there, companies like STERIS, 3M. I know that we will probably have some more information on biofilm coming up here from Key Surgical as well, but there are tons of resources out there. And really talking to your vendor partners and things like that they should have some great resources for you as well.
Brandon, great job. I think this was a much overdue topic, and I know a lot of people hear that term biofilm but don't really have a way to relate to it. I thought you did a really nice job of you and Mike both really characterizing what biofilm might look like in the regular world environment all around us every day. So thank you for that, and excellent first appearance here on Beyond Clean.
Thanks, guys. I'm really glad I could come and nerd out with you a little bit today, and I'm looking forward to hopefully coming on again in the future.
Well, you definitely came to the right crew of nerds, there's no doubt. That was Brandon VanHee, Clinical Education Manager at Key Surgical. Hank, we talked a lot about biofilm. We've alluded to biofilm, or touched on it, I'd say, several different interviews past, but it's nice to take this deeper dive. And something that we really didn't get too much into that I thought was a really good point of Brandon's that maybe we can bring up on a future episode would just be talking about the importance of the instruments being in good working condition, no pitting, not broken, and also just some of these difficult to clean instruments, just trying to figure out, what is the biofilm risk in those scenarios, the nooks and crannies, as I like to call them, especially the ones that you can't get a brush to. Would be interesting to know a little bit more about that as well. So maybe we can have Brandon back on again for a future episode and take an even further dive into this topic. I feel like we went pretty in depth today as it was already.
That's right, Justin. This is one of those topics that's not going away. As long as there is sterile processing and microbes, there will be biofilm. So this will be one of those topics that it's just really incumbent on the part of not only frontline technicians, but also department leaders to educate yourself and continue to educate yourself on not only what it is, but how to battle it. I think one of the big takeaway quotes, for me was know your enemy. And in this context, your enemy is time. And at the microscopic level, all these little formations that are happening because of time and lack of proper point of use cleaning, as he discussed. But yeah, great interview here. A lot of great information, hopefully, for the audience to take away and make a change today in their department. I'm really excited about this. And as we say often, I'm excited about having Brandon on again to talk about a totally different and yet still exciting topic.
All right, well, that's going to do it for this week's show. As a reminder, you can help support us by subscribing to Beyond Clean on iTunes or Stitcher, and now also on Google Play and Spotify. Simply search for Beyond Clean Podcast. We'd appreciate a rating and a review. Your feedback is important to the show, and if you have any topics that you'd like us to cover on a future episode, or if you'd like to share a picture anonymously on our Instagram page, just send an email to info@beyondclean.net. On behalf of Hank, Mike, and myself, thank you for listening to another edition of Beyond Clean.